Okay, well, thanks for the kind words, Mario. Indeed, I am a senior principal product manager at Oracle, but a very new addition. So I started in December last year, which is hugely exciting. And I'm also very happy for ITOUG to give me the opportunity to speak about something that's been very close and dear to my heart for a long time. And it is, as you say, a topic of this presentation is going to be how to gain confidence in database changes. And when I thought about the content of this, I thought there is two ways to doing this, and one of them is to kind of follow a manual approach, which I go and show you first. But there's also the opportunity to automate the entire process, and usually this goes hand in hand with a set of other procedures that run automatically. But the database has very often not been part of these automated procedures. So I would like to show you later on how you could potentially do this. And I also recorded a few demos. Because I have been once burned, twice shy. I had a problem with one of my live demos in an earlier conference. So I decided from now on, I'm going to record everything. But on the other hand, some of the things that I'm going to show you take a little while. And the benefit of using a recording is that I can go at a higher playback speed. So we don't have to wait for a change to complete, because it would be pretty boring. Okay, so let's get started. First of all, I would like to present the usual safe harbor slide that we show at the beginning of presentations. I don't want to spend too much time on this, it's pretty well known. About myself, like I said, I'm a product manager for Oracle, and I joined in December. And if you've got any questions about anything you're seeing here, you can reach out to me using email, Twitter. And there's also a blog which has gone a little bit into hibernate mode at this point in time, but it will, once I find more time, I'll go and resume blogging. Okay, so the agenda for today's talk is this one. So first of all, I would like to introduce some of the DevOps concepts very gently before talking about support in the tools chain. So first of all, like I said, I would like to demonstrate the manual approach on how you could use change management, version control, and deployment of those changes. And I've created a little demo, which is really a little demo, and it's not much than hello world, but it shows you the most important concepts, and it can easily be extended. And once we understand how to run this kind of manually, I would like to show you how to automate the entire process. And this uses a cloud offering called Infrastructure DevOps, Oracle Cloud Infrastructure DevOps. And I'm going to show you how you can deploy changes completely automatically, adhering to some of the best known methods in the industry. I wouldn't want to say that this is the only way how you can deploy these changes, but it's a way that feels very intuitive and natural to me. So this is why I'm showing you these tools. There are other tools that can potentially do similar things, but they're out of scope of this talk. Okay, so now let me make a case in favor of automated and mostly hands-off deployment of all code. And why is this so dear to my heart? I've been using the Oracle database since 2003 as a DBA, and I've been supporting more software releases in various companies that I've worked for than I can remember. But the one thing I can remember is they were usually somewhat, well, shall I say, cobbled together, because in releases, you very often have multiple components. You've got user interface components, you've got backend components, and maybe infrastructure changes even. And the way these get bundled together in my early days of my career was usually by creating a compressed archive, like a tar file or a zip file of all the changes. Developers put them together and handed them over to the operators. And there was usually very little confusion. Well, in my case, there was not an awful lot of communication between the two teams. So essentially, the ops team was asked to deploy something they didn't really know. And so the one thing that is consistent throughout the 20 years of my career is time pressure. There is never enough time to get something done perfect. But that, of course, depends on your definition of perfect. But there is usually a non-standard way on how things get deployed, at least in my experience. And this leads to many problems, such as, has a given change been applied in environment X? So lots of places I have seen use more than one development environment. And then it was difficult to track what was applied where. And a lot of time can be lost by trying to work out if environments are in sync, and let alone the fact that you can assume an environment is in a good state when it isn't, and then you deploy to production, and then all bets are off. So there has to be a better way of doing these things. And this leads me to the next slide. And very often when we talk about automated deployments, you talk about DevOps as well. So this is kind of a play of words where developers and operations, or the teams responsible for those two areas, work together jointly, where the lines between the two are blurred, where it's no longer clear what's ops and what's dev. Because frankly, what you do as a system administrator, you write infrastructure as code, for example, if you're deploying to the cloud. And that's kind of a developer task. And similarly, you could think that developers do the same thing. So, where is the line now between development and operations? It's getting very much blurred. And the whole DevOps concept that is relevant for this talk, I would like to point out, is the build part and the test part, and obviously the deploy part. And these are the areas I'm going to focus on. But before talking about adoption and whether everyone should be doing this or not, there is a very important thing that I have learned over the past years of my career, is just because something is currently hyped or everyone seems to be doing it, it very much depends on your in-house teams, on how quickly you can follow the thought leaders in the industry. Obviously, the more experienced your teams are, the quicker you can move. If you already use a lot of these technologies in-house for, say, front-end development, it's easier to apply the same techniques to the database, which isn't necessarily the case these days. If DevOps is something totally new to you, it's advisable to take it step by step, because otherwise you're going to struggle implementing those things. And it's very important to point out that DevOps is not a product, although there are obviously products to support the ideas behind it. It's a change in culture for many. And as I said, DevOps practices can be useful in many ways, but it is very important to engage everyone. And there are some people who may not be comfortable with change in culture because they have been working the way they have worked for a long time. So pushing a DevOps culture without buy-in from the stakeholders is not a guarantee for it to succeed. And this is why I'm saying that a gentle approach is probably more beneficial than a big bang. So let's start off with the tools that you can use to support these. So Liquibase is the option that is part of this talk. Liquibase is an open source database independent library, and it allows you to track and manage and apply database schema changes. And the true power in it is the state keeping and the audit trail that it generates. And SQL implements Liquibase, but it enhances it at the same time. And it allows you to create what we call change logs, and I'm going to talk about those in a bit, for individual database objects or entire schemas. and it can easily reverse engineer what you have. The thing that it does great, and I'm going to show you this in an example later, is support for rest of services configuration. So you can kind of reverse engineer the rest service configuration of your database and store it in a file and let it run by Liquibase. And it can even export Application Express. So in my opinion, SQL and its built-in support for Liquibase, they're both key enablers for this continuous integration and deployment theme that is key to many DevOps concepts. And let's see how this works. First of all, I'd like to clarify some terminology. So Liquibase, SQL and Liquibase generate change logs. And a change log is a collection of changes to be made to the database. And it can be written in SQL and it can be written in XML. And SQL nicely generates those change logs for us automatically, either for the schema for an individual object, or the auth configuration of the rest of services, or the Apex application, which is pretty cool because it saves us a lot of time doing those changes. And the change logs are organized in change sets. So there is a one-to-many relation between those. However, a change set is an individual change to the database, depending on the change type. And that leads me to the third column. So it can be adding columns, changing the column definition, and so on and so forth. I'm going to show you what this means in a demo. But where is the benefit of using SQL and Liquibase? So the development experience improves, in my opinion, because you can now take what a developer A has created and replay it across any number of environments. And it'll be always the same because there is no ambiguity. And it's also the same format for all database changes rather than a bunch of SQL scripts. And they all follow the same logic. So there is standardization. Repeatability of code execution is also very important. And this is something I like because I've been writing a lot of Ansible code. The concept here is idempotency. So you can run the same thing multiple times and you will always get the same end result. Accountability is important for someone who wants to know, has change X been run against my database, because it keeps track of what was deployed when and where. And security, with this tool, it should be more difficult to inject malicious code because the Liquibase engine stores metadata in the database as well. So you can compare the MD5 sums of things that have been applied. So anything you do with SQL and Liquibase, in my opinion, makes total sense. And I was wondering why I haven't used it sooner. Okay, so let's show you an example of how this could work. And I'm, like I said, the example will be pretty much Hello World style. So not very sophisticated, but it should show you the general ideas. But first of all, I would like to point out that development environments are often a point of contention. Developers often need a copy of the database or a level playing field. And sometimes you can use Oracle 21c.exe because this is the same database, it's easy to use, and it has all the features. And it's also addressing one of the main pain points that I have heard is that it takes long to install Oracle. So just to show you that it is not necessarily the case, I'll switch over to example one. So in this example, I'm assuming that that we're creating a new application and it requires a table named M and a sequence to populate its primary key. So you can see the code to the left. And this is the first step. So we have a requirement to create a new data-centric application, and the developer starts creating the objects in the schema as per the specification. And as you can see here on the left-hand side, this works pretty well. You put it into a SQL script, you run it. And now, if I may, I would like to switch over to how this could be done. And let's play. So here I'm on an Oracle Linux 8.5 environment, and I want to start an Oracle 21xe database using Podman, which is the standard container runtime in Oracle Linux 8. So now if we time from 17 seconds, it's now creating the Oracle 21xe database. I'm creating it using a persistent volume, so the data base gets reused next time I start this. This is the first time I'm using it. And I'm supplying the password as a podman secret, which is more secure. So when database container starts up, it realizes this is the first time it started up. It initializes the database, as you can see, resetting system passwords. And the database is ready to use. And that was about 30 seconds. And this is now an environment that I can use for prototyping, because this is a new application. So here I'm connecting using SQL CL on the same host, and I connect against localhost xvpdb1. This requires obviously the port 1521 to be mapped in the podman command. So there we go. I'm connected now. I can select the name from the database, and I can show my container name. And that's it. Now I've got an environment where I can create my M table. And here we go. I've got another demo for this. I've got a script because everything should be scripted. It essentially creates the objects that I have mentioned. I've already connected to a schema called my app because I'm not very creative. and it lives in xvpdb1, the same that I've just created. So I can run my local code. And there we go. I've got a table, an index, and a sequence. So this concludes the first step. So now I have my baseline. Okay, so this is essentially what you saw on the slide. And it's, as you can see, it's pretty quick to have an environment to play with. The next step is, once the developer is confident that he has completed the specification or completed coding against the specification, now it's time to actually make that code available to others. And the traditional workflow outside the database, more so than within the database world, is to create code or files and inject it into a version control system. And this is what we would like to do here as well. You can do this manually. So you can run DBMS metadata and put that into a nice script, and then manually, call the scripts one after the other in the correct order. Or you do this automatically in SQL CL. And since I'm an inherently lazy person, I would like SQL CL to do the job for me. And the command you can use here is gen schema. This is just one of the options you have available. There is another one where you can create DDL for individual objects. But since this is a new application, I just create the necessary data for my entire schema. And this takes a little while, a few seconds until it's complete. Okay, so once, interesting. Right. Sorry for that. So once this job to generate the schema information completes, there are a few things worth pointing out, and I've got them on the right-hand side. So first of all, you've got a change log for the sequence and a table. As you can see, I'll switch here. So these are the change logs for the sequence and for the table. And there is a master change log, and it's called controller.xml. That's also created, and you see it includes the table and the sequence. And it also does this in the right order, right? Because the sequence needs to exist before the table. These files are created in XML formats, but you can also specify them to be optionally created in SQL alongside the XML files. So there is the -SQL option to LB gen schema. And once this has been done, it's XML files. And XML files lend themselves pretty well to including into source control. And the LB gen schema creates all of this. I have a little directory for my application, and I'm going to introduce source code control to it. Now, the main files I have are within database-schema. So you see the controller XML, and you see the sequence in the table. And now I can use Git to add those files into version control. I should point out that it is not the best practice to use the OPC user in this cloud compute environment. So you should use a lower priv user, but yeah, it's an oversight on my part. What you can say is you init the repository, then you ask it, query its status. There are no commits yet. There are files to be added. So let's do that in the next slide. So I add all the files. I then say git status, changes to be committed. So this is the change set that I need to commit into Git. And I can do this using git commit. I give it a little comment because it's the first one. It's my initial commit. And then it lists all the files it's committed. But there is one thing I would like to point out in Git versions that are a little older. The default branch name is called master, as you can see there. But I didn't like that. I would like to use more inclusive language. So in this case, I rename the branch to main, and then it reads on branch main, nothing to commit, working tree clean. So we're good. And with that done, now I have my local directory under version control. As soon as I make any changes to it, they will be flagged by Git. I can make amends, I can change the code, I can add other things. But the one great benefit of using Git, for instance, is that I can make use of central code repositories that are usually web-based, and the most prominent examples are GitHub and GitLab. But there are others, of course. And within those environments, you can define workflows on how you would like to handle things. But one of the first things you can benefit from is sharing. So you can share the code that you just put under version control with other developers. So let's say you've got a front-end developer, and that front-end developer has a copy of the database that is currently empty because we don't have a master to copy from. And that developer would like to start coding. So that front-end developer or whatever other developer can now take the code from the central code repository and use the lb update command to apply the changed sets and change logs that were generated by us previously. So generally, what it would do is they would, download the repository to their local workstations. And in my case, I'm on dev workstation 02 rather than dev workstation 01, which I used previously. Again, apologies for the poor naming. And once that's done, I can connect to my XE PDB2. So that's a different PDB on a different workstation. And there is no data in this. So the tables command is =cl returns 0 rows. So there aren't any tables. The next step is then to run lb update and providing the change log. And this is called control XML by convention. And then you can see the output script runner executing. And it executes the emp sequence XML and the emp table XML. And these are the two files that are referenced in controller.xml. And ideally, what you see at the end is errors accounted 0 and the number of tables that have been created. So first of all, you've got the emp table, but you also have a few additional metadata tables that are created by Liquibase. And those are database changelog actions, and there is a log table. So the Liquibase ensures that only one person can run the lb update command at a given time. So now let me show you what that might look like. Close this and replace with that. Let's run. So now I'm assume you're the second developer, like the one responsible for the front end. Right now, I'm collecting information from user objects. There's nothing. There's no table, no nothing in my schema. It's completely blank. And I'm in the correct directory, database schema. Now I can run lb updates, provide a change log by the name of controller XML. And it takes literally no time to apply. There we go. Let's apply the two. No errors accounted. Wonderful. Now I've got my emp table, as well as the 3 metadata tables that I spoke about. So if we look into the database changelog table, this is quite interesting because you can see the ID of the script, the authors, the files, the date and order in which they have been executed, as well as the checksum. Now, if I run a command against that query table to see what has been done so far, I had an empty schema before and 2 files have been executed. And just to show you that they have been executed in the right order, I'm editing my query to include the order executed. And there you go. So the sequence has been executed before the table. Otherwise, we would have had run into problems because the sequence is needed as a default value for the primary. Okay. So there we go. It's as simple as that. But development never stops, right? there is always new requirements. Applications evolve over time. I have not yet seen an application being retired. So new stuff needs to be added. And the way this is usually done in the Git workflows is using feature branches. So this is, you start off with branch main, you do your initial commit, and then you branch off. So you create a new line of code that is separate from your main code. You develop this until you get to the stage where your specification is implemented. And then quite often you commit all your changes, they get reviewed, they get tested. And once they are deemed okay and not break anything, they get merged into the main code line. And your application then gets rolled out to the end users after unit testing, regression testing, and integration testing. So the one thing to keep in mind is to give those feature branches reasonably good names. So in here, whatever you call it, issue number, ticket numbers, whatever, you check it out, you add the new branch. And then let's assume we need to create a new table and a few and the foreign key and the procedure. So this happens now on XEPDB1. The individual developer continues working on the code, and voila, everything has been created. The workflow then is exactly the same as it was before. You run lbgen schema in SQL, which I haven't shown you. On the right-hand side, you see the changes in Git. So you're on the feature branch. You see a few files have been modified. Controller XML has been modified because there's a new table that has been added to it. The M table has been modified because there's a new column. And there are new things such as index procedures and ref constraints that are to be created. So if you add those files and commit and push, other people can make use of those. And that's what I would like to show you next. So the developers communicate the change to their peers so they can incorporate them into their version of the code and their local development databases. And let's say unit testing has passed. You can run lb update again, pointing to the controller XML, and it runs against the database and it executes the changes to the depth table, the M table. It adds the foreign key, adds the procedure, and it just creates the foreign key and then the index on the foreign key as the last step. So you can, again, you see all of these in the metadata tables. And this is really where this tool set and tool chain shines, in my opinion, because everything is always being kept track of. So you see the sequence in which these things have been executed, and you can even see what it did. So if I look into the database changelog actions table, which is different from database changelog, I can figure out what has actually been done for the file called index/ifkm-depth-index.xml. It shows the SQL that it used to run against the database. So plenty of stuff to keep developers informed about what has been executed against their databases and how. Now, the one thing I would like to add, though, is there should be automatic testing of schema changes at important milestones. And the way to do this is by using automated deployment and integration. So this is part of the OCI DevOps service. Just really quickly, the DevOps service integrates a build pipeline and deployment pipeline, so both parts of the CI and CD paradigm, in which you commit your changes on the left-hand side against the code repository, which then triggers a build of your application, and then you test your artifacts that are created. And once they pass the test, unit testing, for example, the artifacts get stored in the container registry or the artifact registry, so a container image or a jar file, for example, if it's a Java application. And once that's been done, you can deploy these things to dev. You can run further tests, and after approval has been obtained, you can deploy, and you can deploy to VM and bare metal or the Kubernetes engine or to functions. But this is a lot more than I'm going to talk about in this presentation, because I would like to focus on the database. So how could you do the same thing using this tool set on autonomous database? In order to do this, I would like to show you the second part of my demo, in which I'm using a few components. I'm using the OCI Vault to store passwords, and I'm using a build pipeline because I'm staying with the database for this one. And obviously there is a code repository which contains my code. So before diving into a few more recordings, the high-level steps of this demo include the following. First of all, I define a build pipeline. And in my build pipeline, I create a clone of an autonomous database. And this clone is necessary because it's usually advisable in DevOps parlance to create a local copy of the entity you would like to test against. And in my case, I've specifically prepared the autonomous database array, and it's my gold image used for development. It's security hardened as per the company standards. It contains all the users necessary for operations to support this environment. It's almost like a prod environment in that it is kind of ready to be used for testing against. And in some circumstances, it may even be a prod environment. But this obviously depends on your local security standards. It's not always possible to take a prod database and run tests against it, even as a source for the clone. I mean, you wouldn't run against prod straight away. You follow the standard way. How do I then get all my changes that I have prepared applied against this clone of the autonomous database? I'm using SQL and Liquibase again, because it makes it really simple to do so. And it also simplifies my code quite a lot. And I'll show you how this is done. In this example, I'm creating a table, and I'm REST labeling the schema, as well as one specific REST API call to get data from the table. But because it needs to be secured, I'm using OAuth to authentication for the REST API. And there is nothing I do manually. All of this will happen automatically once the clone is there. So this is important. In this whole process, no manual intervention should be necessary. And the result should automatically be returned from the pipeline, indicating success or failure. Obviously, failure needs to be investigated further, but a green light on your pipeline is what you're after. And just to make it a little more realistic, I wrote a small JavaScript application that I deployed in a container against Oracle Container Engine to consume the REST API. Okay, let me then walk you through by closing this window and opening that window. All right, so this is the DevOps project that I have created for this presentation. And it contains a code repository and it contains a build pipeline. So if I dig into the DevOps repository, this is my Git repository from earlier, and it contains the specification for the builds called build spec YAML. And this is what you see on the screen here. So this follows a specific format, which is documented in the OCI docs. And before moving on, I would like to show you that you can reference environment variables in here and multiple types of variables. First of all, classic environment variables, such as the SQL CL staging location, the database name for the clone, and the name of my schema, and which database to use as a source. And these can be hard coded, and it's fine to do so. Otherwise, anything you don't want to hard code, you can pass in as parameters. And I also need a compartment in OCI where this is all going to end up. But the really cool thing here is indicated here by vault variables. So if I go to my vault, you can see that I have my user password and the passwords I need to create the autonomous database. I have stored them in the vault, so they pre-exist. I don't have to mess with passwords anywhere, which is always good. So the ADB admin password has the OSID of the vault password, and so on and so forth. The first thing is I define SQL CL as an input artifact, so it automatically downloads it, and I'm unzipping it to a specific location that I know. Then I create a clone of the source database by means of a script called deploy.sh. It's all part of my repository. And in here, I'm using the OCI CLI to create an autonomous database from a clone, and everything that I need is kind of passed in as a variable. And maybe if I go back just 1 second, the important thing is highlighted here, because if you run OCI commands, these usually return with, yes, we received the work request, now they asynchronously process it. And at this point, the next steps in this pipeline would fail because the database isn't available. So I'm telling it to wait until the resource is available, so the database is available, and I give it a max wait time as well, after which I say just, okay, it didn't work. And then I get the OSID, which requires some fancy JMIS pass arithmetic. And I store the OSID of my newly created clone, and I need that to generate the wallet. And I pass the database OSID in there. That once the database has been created, I can deploy my schema changes, but quite importantly, I have an option to define what happens on failure. So I don't want to have databases hanging around, costing me money. On failure, I just run the reverse and remove the database. And there is a force option to it. But once the database has been created, I can deploy schema changes. And this is the next thing that you see in this file. So it uses the bash to echo a few commands into SQL CL. Essentially, it runs LB updates for the controller.xml, and it runs LB updates for the data. So this is another option I haven't mentioned yet, but you can also define data to be loaded via Liquibase interface. It's for small amounts of data only. Don't run this and load tons of data, but for a few rows in the table, it works. So you see the only file it references is the end table XML in the table subdirectory. So there it is. And then it's got the data, and this contains the rather well-known content of the end table in Liquibase's format, in XML format. So if that fails, again, I can remove the database because I don't want to hang it around. And then the next step is to REST enable the database. And I've got a specific repository there as well. So this has been generated by SQL CL's Liquibase ports, but it didn't create the REST client that I created. So there is an important thing to notice. I can add files to Liquibase, of course, and I can follow all the conventions that they use for building those. So this is a file in SQL because I need a pure SQL file. It just needs a little bit of metadata in the header, which is shown here in the highlighted comments. So this runs. You would obviously support some more reasonable email addresses and support links. But this is essentially it, right? So this is the build pipeline. And once this has been defined, I can run it. And this is where the fast forward really comes into play. So I'm now back in my project and I run the build pipeline. So you click on it and you can see how it's defined. There are multiple stages that you can define, but in my case, it's only one stage because I would like to create my clone of the database, and it references the YAML file I just showed you. There we go. That's the file. You can even edit the stage at this point if you wanted to, so you can see how it's defined and what it does, including timeouts and stuff. Right. Start the manual run, give it a name, or take the default. I take the default. And this is what you then see. You see the various stages. In my case, it's just one. And it accepted the work request. And this is where I'm going to fast forward. So you can see it's in progress. And then you see the various components that I have defined in the YAML file. Everything in lowercase is what I provided. So it's unzipping SQL, creating a random DB name, which is necessary because autonomous database names live in a given namespace and they can't be duplicate database names. Then I create a clone of the database, which obviously is what takes the longest. And fast forwarding still.
Yeah, yes, thanks, Martin, because there are a few minutes still before the end of this.
Yeah, I should finish in 5 minutes, I promise.
Oh, okay, thank you very much. sorry for the interruption. Please go ahead.
No, it's no problem. I should be good in time. Yeah, this is what I say. Recordings are way better because I can just fast forward. So you saw, it created a clone of a 1 terabyte database in 5 minutes, which isn't too bad at all. And then it completes all the rest of the steps. And what you would like to see is everything here in green. Now, with that being said, there is success to the build. And I can now jump to the database. The logs, you can also download the logs, obviously. But this is what you would like to see. And this is where you could do additional things. And there we go. This is the database. And the database name is no AXMP, which is a completely random thing. So let me just fast forward to that database. Now I can open the database options and connect. Just to show you that entering the SQL module, I can show you what's been created by the user my app. So you see the AMP table with all the columns, with all the data. And you see the change log as well. So it shows exactly what it did. And finally, what I would also like to show you, and I'm conscious of the time, I'm signing out as the admin user, signing back in as the my app user. And you can see that I have a REST module there, which is secured as well. So moving through, I can see the modules and the handlers and the actual data. And very importantly, if I try to open this link, I should get an HTTP error because I'm not authenticated. Okay. And the client has also been created. And just to wrap it up, I can get the bearer token from here, which I need for the OAuth authentication. I can now use this in my application. And I'm going to skip towards the end. I don't want to show you that. So how we created it in Kubernetes. There we go. This is the application that I've deployed via Kubernetes and the service that is externally accessible from a given IP address. And if I open that IP address, this is the application. I configure the endpoint for my API, which I grab from the OCI console. Okay, I've refreshed this token. They're very important. Token wrong means it would work. and I can copy the URL of my API endpoint to the clipboard. And if I put that in, I can fetch the data. There we go. So, and with that, weird why it does that. I'm going to wrap up. And I think automation is key when it comes to application lifecycle management. And the more automation you enable, the greater the benefit. But it's important to learn and adopt new technology at your own pace. And just to recap, I've used the build pipeline, and it can easily integrate things such as linting of your code, so checking it for style guide and correction, code coverage checks you could include, unit testing you could include, and then you produce an artifact. But you can also create the database as I've showed you. I haven't shown you deployment pipelines, but they could easily deploy that little application I wrote into the container engine. And as I said, database changes can be integrated into these workflows thanks to SQL's Liquibase support. And yeah, I'm 1 minute over, I'm sorry. But yeah, that's what I wanted to show you. And if you've got any questions, feel free to reach out to me on my email address or my Twitter handle, and I'll be happy to come back to you. And I'll hand over to Mario.
Oh, okay, thank you very much, Martin, for your presentation. Very interesting. And if everyone wants to ask something to Martin, can write inside the chat that is available to everyone, so I can ask directly to Martin. Okay, there is a question from Salvatore Sorce, and the question is, are there any database objects which are not supported by Liquibase?
I know that there is a list of objects that are supported. So where you can find this information is in the SQL user guide. There is chapter 3 titled Liquibase Support, and that gets updated with every SQL release. So what I would suggest is use your browser and navigate to that page for the current release of SQL, and you can see the schema option support, object support, sorry, and it lists them all there. I don't know off the top of my head which ones it doesn't support and which ones it supports. It does the majority of stuff from what I remember.
Oh, okay, thank you, Martin. I can see now another question on the chat, but really I have a question for you from myself,
Sure.
because I also use sometimes change on database, and I also used to manage this kind of change using Git that you shown in your example. Mm-hmm. A suggestion from you, but not in the specific of related to the presentation that you have done today, but something related. When you have to manage more environment, for example, a database for developers, a database for the test environment, and a database for production, okay? And I want to manage all my changes. For example, I create a new patch in development environment, and I have to apply this on the development database. Then everything is okay. I have to move the same patch on the test environment, and at the end on the production environment. Some suggestion that you can give us to manage this kind of situation, how you can suggest something about this, a quick way, a best way, something that you have in mind in your experience.
Yeah, and this is I can show you. I don't think I showed you the update video because I could already see that we might be a bit tight on time. this is really the way you could see things being done. So you create your changes, they are staged in Git, they are made available to the other developers, and then you use the lb update command on the database where you would like to apply the changes that you have been creating. So what in my case, it's simple because it's like I said, it's kind of a hello world example where you simply create a table and you modify the table and you generate the schema DDL by using lb gen schema. But it's in environments where you have already plenty of objects in there and you would like to make changes. It's not uncommon to just create the Liquibase change logs for the object you change and then apply these. But the idea would be to use the lb update command to apply those changes from one environment to the other. And this way, as you can see in the database changelog table, everything is being kept track of, and you can compare one environment to the other and see when has a script been executed, and have I executed all the change logs that I need to execute in order for my application to deploy. And that's probably the way I would do it. But like I said, reverse engineering schema usually for well-established, historically grown applications, that is probably not the best way forward. But creating a branch of your repository with the new things that you would like to execute, and then creating the change logs using lb gen object, and that's the command for that object in question. That might be the best way forward if you want to follow this approach of using Liquibase and SQL.
Okay,
I hope that makes sense. That was a lot of talking.
No. But I think it's quite clear the way to follow that have to follow in this kind of situation is quite clear, because obviously checking the version applied inside the database and something like this can be very useful. The order executed, and so as you shown us. Okay.
Yep.
Thank you very much, Martin, for everything you have shared with us. And this is very important for us that you are here with us, and for everything you have done for us. Okay, I think a lot the same words.
No, don't worry, it's all cool. I'm super happy for you to keep the community spirit up. I have been a community person for all my Oracle career, and I really appreciate all the work that you guys put into this event, putting it all together, investing your own time as well. So thank you very much for keeping that alive. It's very important in my opinion, and it's great you're doing that. So thank you very much.